One, two, three. All right, I'm back with an intense coding session. I told you coding is not my focus, but it is a necessity. So, no excuse. It sucks. I know you want to mental master way, you want to be on your paper, write down stuff, solve mathematics, but let's be honest, nobody gives a fuck unless you can implement it in a code. And you may say, yes, there is chat GPT that does whatever code I need. But man, that's the game. That's the game of interviews. You want to get to a good company, they want even a bad company. Just learn the shit. It's easy. So I already put my Jupyter out, and what are we doing next? Okay, the problem we want to solve is called Roman to integer. Get your keyboard. Lit code. Let's go. Roman to integer. It's an easy problem. I wanted to start easy. Who wants to solve difficult problems? Dude, there is no point. By the way, there is no point in solving difficult problems. That's too much. Always solve easy problems. So what is Roman? Roman numerals are represented by 7 different simples. I, V, X, L, C, D, and M, which M stands for 1,000. So at the time of Romans, they couldn't go, for example, over 1,000,000 or something like that, I guess. For example, 2 is written as 2 other than. So the thing is that we have, it's the Roman to integer code on lead code. Dude, I know. A lot of you reached out to me. I feel it's like over 10% of our team that we hang out with each other. We are all friends, by the way. I love your feedbacks that I cannot appreciate and cherish them more. Told us that we want the screen. I'm on it. One of my friend told me about this app OBS. I will make it happen. Okay, so it is Roman to integer on lead code. Let's go, guys. Written. So there is this string of Roman numeral, and we want to say what is the integer number. Oh, 27 is XXVII. So they could go like 10 M's. They could go up to 10,000 and 10 D's. Like, what is it? 15, 1600, 1600, 1666. What is 1666? It's a, let's see what happened in 1666. Major events in it is actually MDCLXVI year. Oh, 1666 was a watershed year for England. An outbreak of the Great Plague, the eruption of the Second Dutch War, and the devastating Great Fire of London. So isn't it interesting? Just randomly all of you, my conspiracy theorist friends, this is just for you. This part, 1666, Wikipedia. It also has a Wikipedia page. Oh, it's all about it. MDCL XVI was a common year starting on Friday of Gregorian calendar and a common year starting on Monday, Julian. Armenian calendar, Syrian calendar. How many calendars do we have? Nanakshanhi calendar. Interesting. Really? I didn't think. I thought we have like 3 calendars. 4. Ooh, Syrian calendar 6416. Dude, they started the history way back. Which one is the earliest one? Bengali, Syrian is Byzantine calendar. It is 7174. Wow. Anyways, let's not get distracted. Holocene character. It is 11666. Nothing. Nope. Oh, Thai solar calendar. What about Persian calendar? What the fuck? Oh, Iranian calendar. What happened in that year? 1044. In Iran. The second Shah Abbas, which was not a very gangster king. All right. All right, Roman Empire, by the way, good show on Netflix. I cannot emphasize it more how important it is for you to watch Roman Empire on Netflix. It's very good. All right. Usually written largest to smallest from left to right. However, the numerals for 4 is not 4 I's, but it is IV. So we have this exception. 9 is also IX. And then we have 40 and we have 90, right? Yeah, 40 and 90. And we have 400 and 900. They are the exceptions. So now we receive an Roman numerals and we want to turn it to a integer. What is the problem? Well, do the exceptions make it hard? Yeah, definitely. It's all about the exceptions. Otherwise, I would read a string from left to right get every letter and would say, all right, this is wrong because why? This is wrong because you tell me, okay, if there was no exception in the number, I would get the string. I would get every, what do they call it, letter? What are the elements of the string? Dude, I haven't coded for so long that characters, right? Characters are the elements of string are called characters. All right, so I would grab each character, and if it was m times 1000, maybe we can have a dictionary built for it. So m ding dang ding dang dang, sum them, and that's it. Now it's not very difficult to find an exception, right? You get the string, you have the string, you have each character, and you have this order for the characters, and you are going from left to right. Once you reach, and you're okay, exceptions are easy to find. You look at the character, and if the character is not in that order, if the next character has a higher order than the current character, it shows that we hit an exception. And instead of a plus, it should be a minus. That's just it. Well, it depends if they also expect us to see if we can detect a wrong Roman numeral. Didn't say anything here yet. What happened in 1994? MCMX CIV. Okay, also part of the question, it is guaranteed that S is a valid Roman numerals in that range. So we do not need to check if it is valid. I want to know is, oh my god, I'm so fucking tired. And I still don't know why does in leet code every solution should start with a class. Let's ask ChatGPT. Oh my god. Alright. Why do solutions in Why do solutions in leet code need to be in a class? Format. In leet code, solutions are, I wish you could read it for us. What is it? Alright, bullshit. I will ask this ChatGPT. Why do solutions in leet code need to be in a class format?
Solutions are typically required to be in a class format because it aligns with object-oriented programming principles, which are common in many programming languages. Classes help organize code, encapsulate data, and provide a clear structure. Also, LeetCode's online judge needs a consistent format to execute and test your code against various test cases. By using a class structure, it ensures that your solution can be easily integrated and tested within their system. This format also allows for defining methods and variables specific to the problem, making the code more modular and easier to debug.
Alright, so it is just LeetCode wants to do the judge system of the LeetCode requires it. Alright. Yeah. Alright. Let's open it in my Jupyter, which is my kind of a scratch paper. And then once we're done, with the help of ChatGPT and our thinking experiences, we will send it back to LeetCode where it belongs. Python 3. I'm a Python 3 user and ChatGPT 3.5. Occasionally I go ChatGPT 4. Alright. That's it. Class solution, def, Roman to int. It's a function, self s, takes any strings, gives us an integer. So the first thing I need to learn is that once you have, well, I think a string is looks like a list or tuple. That's actually good practice. I like this exercise. So let's say S is Amir. I want to Amir. Alright. And I want to say S of 0. I guess it says A. Yes. And also, what about length of S? S dot length. It should be something that you do like shift and enter or something, and it brings all the functions you can. They are called methods. Len. Is it len? Alright. ChatGPT. How to find length of a string in Python. Alright, my string hello world. Length is len of my strings. So it is not that method. Is there a method, by the way? Let's ask him. It's called attribute, right? Is there an attribute that can do the same, like in Python you can also find lengths using str types. That is not a cool. It is like underline, len, underline. They wrote it in a way you don't want to use it. Okay, so we use len as a function on the string, and that's good. That's what I need, right? So We have the algorithm in our mind. Everything else is just Python syntaxes, which is not very difficult. So what I do is I say n is len of s, and I use a for loop. How do you write a for loop in Python? Dude, I don't know the syntax at all. Oh, wait a second, but also how to find the functions. I don't want shortcut key. Anyway, let's know it. Shortcut key for all attributes and methods for the list. He knows, dude. For a class. In most integrated code editors, you can use the following shortcut to display a list of attributes and methods for a class of objects. Usually Control space or tab, code completion shortcut. Documentation, Control Q if it doesn't context. Right click on your object code editor may also show a list of attributes and methods. For Python, my question is about Jupyter Notebook. In Jupyter Notebook, which is an interactive web-based environment, tab completion in a Jupyter Notebook cell, you can type the name of an object followed by a dot and then press the tab key. Jupyter will provide a list. That's amazing. How easy the life is, and what a kind of a bitch I am not to learn this fucking easy thing. Shift plus tab also works. After typing the name followed by a dot, you can press the shift plus tab. Is it that difficult, dude? Just move your lazy ass. S dot tab. Oh, okay. So for example, I have S. You can capitalize it, you can case fold, you can center, you can count, you can encode, all of them. So one is tab, the other one is, what is it? Shift tab. Wait, why shift tab? Oh, shift tab gives us the information about it. Interesting. Okay. Now I want a for example. For loop. Let's go first ourselves. For I say colon. Let's trust ourselves. Nothing bad happens. At worst, we will look at ChatGPT after. For I will say colon 1 to, not 1, 0 to len of s minus 1. By the way, one of the reasons I hated coding and computer science and tried to stay on the integral side was that these fucking losers start counting from 0, and now they have the whole world in their hand, and we ended up being the losers. So when you enter on Jupyter Lab, it does the indentation by itself. Okay, for I from this to this. Okay, I want also to define the number. What is the number? If S is my string, I want to name my number, and N is the length of it. m. M is my number. I set it as 0. And oh, what the fuck? All right, m is 0. So every time what I do, if okay, I have to define my dictionary here too. I want to do it with dictionary. I think it's a good practice to remind me how a dictionary works as well. So it's usually they use this, what do they call it? Accolades, or curly braces. Give an example. And this easy thing, I was not learning it, and you are not, you loser, you are a winner if you are on Mental Masturbator channel. All right, you are also not learning it. We are also, all of us, not learning it, and it just makes us our life super difficult. Just knowing it a bit makes a huge difference. You don't want to be like professional programmer, but know the basics, and it brings you a lot of opportunities. Give an example of a dictionary. Okay, so person, you have this. So it is, yeah, as I said, it is curly braces. And is it called curly brace? What do you call this? Symbol is called the closing curly brace. Yeah. All right. So it's a string, colon, string, and you separate them with commas. So I want to open my dictionary. I will call it D is equal to enter. I like that. What are the Romans? It's a keyword, right? Symbol value. All right. How can I turn I know, but I want to, I have this cell in my Jupyter notebook. I want to keep it as a reading cell, not a code cell. Let's see where I should do it. Run. Oh, okay. At the top of there is this bar at the top that you can choose code, markdown, raw, NBC convert, heading. If I choose it heading, this is a level 2 heading. But if I choose it as markdown, let's Control Z and choose it as markdown. Now that oh, that sucks. I don't like that. Control Z. Asshole. Alright, it works still. Alright, I stands for 1. OBS would make it terrifying. Alright, V stands for, I should bring OBS. Guys, I promise you, so we can have better interaction with each other. You can be more involved. IVX, X is 10. It's also interesting why they chose this order. Like I is 1, V is 5, X is 10, L is 50. Maybe it's because how they pronounce the word. Yeah, I guess it is it. Again, ChatGPT. How did Romans pronounce 1?
It seems like your question got cut off. Could you clarify which Roman word or phrase you're asking about regarding pronunciation?
1.
It looks like your message might have been incomplete.
No, it went crazy. Alright. Yeah, ChatGPT 4. How can I restart? I want to restart. Ooh, what is this? They added more stuff. Data analysis. DALI, we used to have it. CAD Minion, which is inactive. And they have Open API Builder. How? Dude. Is it this? Fuck you, I will start a new one. Alright. How did Roman pronounce 50?
In ancient Rome, the number 50 was pronounced as quinquaginta in Latin.
So why did they put L?
I'm sorry, it seems like your question got cut off. Could you please clarify or provide more context so I can assist you better?
Why did Romans assign L to stand for 50?
The Roman numeral L, representing 50, is derived from the Latin word quinquaginta, which means 50. It's believed that the Romans used the letter L as a shorthand notation for this number due to its resemblance to the Greek letter lambda, which had a similar numeric value in ancient Greek numeral systems. Over time, this usage of L became standard in Roman numerals, and it has been used as the symbol for 50 ever since.
So L was lambda, lambda was Greek, and they used it for 50. All right. What about X and 10?
The Roman numeral X represents the number 10 in the Roman numeral system. The origin of X as the symbol for 10 is not entirely clear, but it's thought to have evolved from the shape of two crossed lines, which resembles the Roman numeral X. Over time, this symbol became associated with the number 10, and it has remained the standard representation for 10 in Roman numerals for centuries.
How did they pronounce 10?
In ancient Rome, they would pronounce X10 as decem in Latin and L50 as quinquaginta.
All right, thank you. So you can see that. Why didn't they have big numbers? 10, it's just very Greek. It was a big word. It's difficult. Greeks are amazing at letter level for math, but at word level it's so complicated. I cannot learn Greek. It's such a difficult language. All the words are big. I don't know. Ena potiri nero to all my malakas. With I don't know the word. All right. LIVXL. All right, we have 10 more minutes and then we are done for this one for coding. And we want to go watch and when G. Okay, oh, it's here. IVXLC is 100. Do you think I should put the numbers also in column? I don't think so. D is 500. But I have the feeling that it may be a bug. We can check it in another cell. All right, G is 500 and M is 1000. M it's 1000. All right. Let's have this somewhere else. Okay, what if I say D? Is it in parentheses? How do you, should I say D of I, for example? Is it like this? D of, well, quotation, I believe it should be there. Nope. Is it brackets? Yes, and it is number. So we don't need to put the numbers in the quotation, but like for putting the input inside the dictionary, you should use the brackets, not parentheses. All right, we are good here. If, okay, back to our for loop for I from 0 to len of s minus 1. If d of I is less than, that's the exception, right? You have a letter, you have a character, it has less value than its next character. If d of I is less than d of I plus 1, if it is greater than or equal, you just sum. So if it's not inter, okay. M, which is our number that we are, M is M plus di. Do we have else? Yes, do we have else? Well, M is M minus. Sorry. Else M is, which is the normal situation, M plus d of I. All right, and We don't need and, right? Yeah, I guess. We don't need and. What are you doing? Actually, okay. That's it. And return M at the end. Right? Return M. There are two situations I want to also mention. So it is the general case, but it is possible that our string is just only one character. So let's separate it. If len of s equals 1, then we have to return d of why did I say I? Well, that sucks. D of 0, d of s of 0. I like it this way. For I, it should not be d of. Okay, it should not be d of I, it should be d of s of I. Alright. Yes, it should be d of s of I. We have s of I is the character. D of SII is the number assigned to that character based on our dictionary. Alright. And should be again s of I. Also here. That's it. Shift enter. What the fuck? It has problem with my line if len of s return this. What is wrong with it? It says it is an invalid syntax. I will copy and paste to ChatGPT. Alright, it looks like you are trying to implement a function in Python that converts a Roman numeral string to an integer. How understanding it is. There are a couple of issues in your code. I thought there was one issue. Let's correct them. The if statement is missing a colon at the end. Wow, alright. How does it work then? So, okay. The if statement has a colon and you will receive. Alright. I thought I got the if, but anyways, probably. Is it the same for else as well? Alright. Okay. What if I shoot it now? Okay, now our 4 has a problem. I wrote for I semicolon. I guess the colon doesn't make sense here. 0 to L, it doesn't make sense. Let's see what does ChatGPT tells us. Okay, the for loop has a syntax issue. It should use range of len of s. Why? And a colon at the end of the for step. Wait, what is len of s? What is len of s? So it is our s. S is Amir. What if I say len of s? 4. Why should we use range? What is range of ln of s? All right, range. Oh, range of ln of s is range of 0 to 4. Wait a second. Type, I bet it's a least. It's a range. All right. So range of len of s 0, 0, and what if I say 4? We don't have 4. 3 is 3. 4. Yeah, we don't have out of range. What else? Okay, I'm done for coding today. Yeah, I did 45 minutes. Let's go over the other. Andrew, NG.
Morning and welcome back. So what I'd like to do today is continue our discussion of naive Bayes, and in particular, we describe how to use naive Bayes generative learning algorithm to build a spam classifier that will almost
All right, let's go.
work, right? And so today you see how the class moving is one other idea. You need to add to the naive Bayes algorithm we described on Monday to really make it work for, say, email spam classification or for text classification. And then we'll talk about a different version of naive Bayes that's even better than the one we've been discussing so far. Talk a little bit about advice for applying machine learning algorithms. So this will be useful to you as you get started on your CS229 class projects as well. This is a strategy of how to choose an
SVM, guys. I think it's a decomposition.
Starts with intro to support vector. Okay.
Oh, support vector matrix.
The naive Bayes algorithm is a generative learning algorithm in which, given a piece of email or Twitter message or some piece of text, take a dictionary and put in zeros and ones depending on whether different words appear in a particular email. And so this becomes your feature representation. So using the
Let's go.
XJ, I've been trying to use a subscript J not consistently to denote the indexes and features, and art index and training samples. And you'll see I'm not really consistent in that. But so XJ is whether or not the indicator for whether word J appears in an email. And so to build a generative model for this, we need to model these given y and p of y. So Gaussian discrete analysis models these two terms
X given y.
and Bernoulli respectively, and naive Bayes uses a different model. And with naive Bayes in particular, P of x given y is modeled as a product of the conditional probabilities of the individual features given the class label y. And so the parameters of the naive Bayes model are phi subscript y is the class prior, what's the chance that y is equal to 1 before you've seen any features, as well as phi subscript j given y equals 0, which is the chance of that word appearing in a non-spam, as well as phi subscript j given y equals 1, which is the chance of that word appearing.
We had phi function last time.
Okay. And so if you derive the maximum likelihood estimates, you'll find that the maximum likelihood estimates of phi y is this. Right, just a fraction of training examples.
Phi is the logarithm of p.
That was equal to spam.
I guess.
And
because it says phi y is sum of. I don't know. I know.
And this is just the
Phi of y, we have this, and phi j of y.
Emails with label y equals 0.
Yeah, I remember this. We had this.
Did this feature xj appear?
Appear, not fraction appear.
And then finally, at prediction time, let's see. You will calculate p of y equals 1 given x. This is kind of according to Bayes' rule.
Damn, dude. Look at this. Okay. It's my bottle, like, and it's rim. Yeah, like, I think it is the plastic on the lid that is just. Why is it so dirty? Disgusting. Ugh. Should I still drink? No, it is dirty actually. I hope I don't die. I had this bottle forever.
Okay.
Let's see.
All right.
Let's see.
So it turns out this algorithm will almost work, and here's where
Everything almost works.
which is
Actually, we only look for things
every
that
year,
almost work.
We
don't want things that work all the time. Even ChatGPT almost works. It's not that ChatGPT always works. In different senses. It almost works because it cannot answer all the questions. Also, it almost works because it doesn't answer questions all the time. Sometimes it is.
But up until now, presumably you've not had a lot of emails.
Too busy.
Friends asking, hey, do you want
Their
some
network is too busy. Wow, disgusting.
And so, if you use your current,
Look at
email,
this.
set of emails to find these maximum likelihood estimates of parameters, you will probably estimate that probability of seeing this word, given that it's spam email.
What is NIPS? NIPS is the name of a conference.
The number of
NIRPS.
examples
I
that
know.
you've labeled as spam in email. So if you train up this model using your personal email, probably none of the emails you've received for the last few months have the word NIPS in it, maybe. And so if you plug in this formula for maximum likelihood estimate, the numerator is 0, and so your estimate is probably 0. And similarly,
I cannot trust anybody anymore. What is it? What the fuck is it? I thought drinking water is an healthy activity.
It's just this formula.
Now these fucking plastics. We better throw them in the ocean
Statistically,
so that they kill turtles than killing us.
The chance of something is zero just because you haven't seen it yet. And where this will cause the naive Bayes algorithm to break down is if you use these as estimates of the parameters. So this is estimate of parameter phi subscript 6017 given y equals 1. This is phi subscript 6017 given y equals z. And if you ever calculate probability, that is equal to equals 1 through n. Let's say you have 10,000 words. P of xi equals 1. P of xi given y.
Finish it.
So
Finish
if
it.
you train your student classifier on the email you got until today, and then after CS229, your project teammates start sending you emails saying, hey, we like the class project. Shall we consider submitting this class project to the NIPS conference? NIPS conference.
Oh, it is about NIPS conference. All right.
Sort of May or June. So finish your class project this December, work on it some more, right? January, February, March, April next year, and then maybe submit to the conference May or June of 2019. If you start getting emails from your friends saying, let's submit our papers to the NIPS conference, then when you start to see the word NIPS in your email, maybe in March of next year, this product of probabilities will have.
Oh, so they are. The problem is that they are sending something to NIPS,
And so this thing
and they want to receive email, and they want to check if it is spam or not.
And in the same way, this is also 0, right? And
Spam.
this is also 0 because there'll be that one term in that product over there. And so what that means is if you train the spam classifier today, using all the data you have in your inbox so far, and if tomorrow or 2 months from now, whatever, the first time you get an email from your teammates that has the word NIPS in it, your spam classifier will estimate this probability as 0 over 0 plus 0.
0 over 0 plus 0.
Error. It turns out that
That's very bad.
probably have something as 0 just because you have.
I want to sleep, guys. I want to sleep.
Right. So what I want to do is describe to you Laplace smoothing, which is a technique that helps address this problem. And let's in order to motivate Laplace smoothing, let me use a different example. Let's see. All right. So several years ago, this is older data, but several years ago. So let me put aside naive Bayes. I'll talk about Laplace smoothing, and I'll come back to apply Laplace smoothing on naive Bayes. So several years ago, I was tracking the progress of the Stanford football team.
Damn. Stanford has a football team?
That year, on 9/12, our football team played Wake Forest, and actually these were all the state games we played that year, right? And we did not win that game. Then on 10/10, we played Oregon State, and we did not win that game. Arizona, we did not win that game.
Damn, Stanford lost all the games.
Caltech did not win that game.
They even lost to Caltech,
And the
dude.
question is, these were all the away games, all the other state games we played that year. And so Stanford football team's biggest fan. You follow them to every single all state game and watch all these games. The question is, after this unfortunate streak, when you go on, this is actually game on New Year's Eve, you follow them to their Oklahoma game, what's your estimate of their chance of their winning?
Oh, because they were all losing. Okay, so how can you estimate that? You cannot use that estimate because it was summing over all the wins. and there is no win yet, and you don't want to say, okay, there is no chance for Stanford to lose.
If you use maximum likelihood, so let's say this is a variable x, you would estimate the probability of their winning. Well, maximum likelihood is really count up the number of wins, right, and divide that by the number of wins plus
number of losses.
The number of losses.
By maximum likelihood,
so
the odds would be 0.
Estimate this as 0
Yeah.
divided by number of wins was
4.
Number of losses was 4.
Alright.
That's kind of neat, right? They lost 4 games, but you say, no, the chance that they're winning is 0, absolute certainty. And just statistically, this is not. This is not.
I agree. It's too harsh.
And so with Laplace moving, what we're going to do is imagine that
Laplace
the positive outcomes, the number of wins, just add 1 to the number of wins.
Oh, he adds only 1.
And also the number of losses.
Plus add 1. So in the denominator, we have plus 1, which makes sure we don't have 0. Which makes sense, because in long run, you will have enough of both, so that the ratios are close to each other.
6.
In the symptotic behavior, they act similarly. In short term, you don't say that, okay, there is no chance.
There's actually a certain set of circumstances under which this is an optimal estimate, so I didn't just make this up of thin air. But Laplace
was a French mathematician.
Very influential mathematician. He was actually trying to estimate the chance of the sun rising the next day. The reasoning was
the sun rising the next day, okay.
And so, but that doesn't mean we should be absolutely certain the sun will still rise tomorrow, right? And so his reasoning was, well, we've seen the sun rise 10,000 times.
He was a motherfucking mental masturbator. Who says we should not be sure sun will rise tomorrow? He was a mental masturbator.
The sun will rise maybe tomorrow, but maybe not absolutely certain, because maybe something will go wrong. Who knows what will happen in this galaxy? And so his reasoning was he derived the optimal way of estimating, really the chance the sun will rise tomorrow. And this is actually an optimal estimate under. I'll say the set of assumptions. We don't need to worry about it. But it turns out that they assume that you are Bayesian, with a uniform Bayesian prior on the chance of the sun rising tomorrow. So if the chance of sun rising tomorrow is uniformly distributed, in the unit interval, anywhere from 0 to 1, then after a set of observations of this coin toss,
it's not 0, right? As days move on, these odds gets less and less, gets closer to 0. But it still makes sense to have a probability for it.
But mechanically, what you should do is take this formula and add 1 to the number of counts you actually saw for each of the possible outcomes.
We are assuming that there was a day that no sun showed up.
And more generally,
I'm still looking at the.
If you're estimating probabilities for the k-way rapid.
That's it, dude. Say something interesting, I will look at you.
Then you estimate the chance of x being I to be equal to
we have now the more general case is for the more than 2 options.
Maximum likelihood estimate, and for Laplace smoothing, you add 1 to the numerator.
1 to each one of them.
And add k to the denominator.
Yep, makes sense. I agree. No, I don't want to add anything to mine.
The way this modifies your parameter estimates is this. I'm just going to copy over the formula from above. Right. So that's the maximum likelihood estimate, and with Laplace smoothing, you add 1 add 2.
You know, it would be amazing if I could just had a USB cable fucking to my head. That's it. We have this stuff.
And so you implement this algorithm. It's not like
why I don't know why we need to. Okay, yeah.
One nice thing about this algorithm is it's so simple, right? Estimating the parameters is just counting.
It would be nice if I didn't need to learn this stuff and I had them. And whenever I saw the problem, I would say, okay, go to this part of my mind.
All right. Any questions about this?
But it's not possible. At least now.
Yeah.
What the fuck are you doing, Elon Musk?
Oh, sorry. This slide.
By the way. Well, ChatGPT is kind of like that, right?
I was actually following this.
For example, in coding, you finally get into a problem, it solves for you.
They're doing much better now. This was a few years ago. All right. So, in the example we talked about so far, the features were binary valued, and so actually, one quick generalization: when the features are multinomial value, then the generalization. And actually, here's one example. We talked about predicting housing prices, right? That was the very first moving example. Let's say you have a what's the chance that this house will be sold within the next 30 days? So it's a classification problem. So if one of the features is the size of the house, X.
I like that he gives a lot of examples. At least keeps the audience engaged.
One way to turn the feature
practical,
feature would be
real life
choose a few buckets. So if the size is less than 400 square feet versus 400 to 800 or greater than 1200 square feet. Right? So this is how you dispute continuous value feature to discrete value feature. If you want to apply 90 base to this problem, then probably of X.
What if we can do that in the classroom? That would be cool.
P of xj given y, where now this can be a
multinomial.
Right, where if x now takes on one of 4 values, say, then this can be estimated as a multinomial probability. So instead of a Bernoulli distribution over 2 possible outcomes, this can be a probability mass function, probably over 4 possible outcomes if you discretize.
I feel he's a really good teacher.
4 values. And if you have a discretized variables, typical rule of thumb in machine learning, often we discretize.
How many views did it get? This course.
It often seems to work.
Okay, Stanford Online has 500k subscribers.
You have a discretizing variables.
And this course, wow! I thought it gets much more people watch it. Okay, 180k. Wow, 180k people viewed it, but nobody. 1.6k people liked it. That's kind of unfair.
And so this is how you can apply now.
They're watching it for free. Leave a like. Well, I don't do that too, but I like this one though.
There's a different variation on naive Bayes that I want to.
Last comment here is 1 year ago. I feel I am the last person that 4 months ago, 11 months ago, 4 months ago, 1 year ago, I don't know how they keep this 1 month ago. Okay. There is one from 1 month ago. Alright. For a second, I thought like all the humanity learned machine learning and I am the only one who started a year later.
So unless you get an email that's, a very spammy email that's drugs, buy drugs now. This is meant as an illustrative example. I'm not telling any of you to buy drugs. So if you have a dictionary of 10,000 words, then I guess let's say A is word 1, odd is word 2. Just to make this example concrete, let's say the word buy is word 800, drugs is the word 1600, and let's say now is the 6200th word in your 10,000 words in a sorted dictionary. Then the representation for X will be 0, 0, right? You put a 1 there, and a 1 there, and a 1 there. Okay. Now one interesting thing about naive Bayes is that it throws away the fact that the word drugs has appeared twice. Right? So that's losing a little bit of information. And in this feature representation, each feature is either 0 or 1. Right? And that's part of why it throws away the information that with the one word drugs appear twice, and maybe should be given more weight for in your classifier. Does a different representation which is specific to text. And I think text data has a property that it can be very long or very short.
And I cannot check Instagram. Fuck this life.
And somehow you're taking very short or very long emails and just mapping them to a feature vector that's always the same length. It's just a different representation.
What would if like this teacher,
this email,
Andrew NG,
for that email, this is drones by
acted like a
as a 4-dimensional feature vector.
Instagram feed? That's very addictive. That's very engaging. So every minute he should switch to like a motivational speaker, how to make money, and then dance for us and put some music, and then 1 minute of this. That would be nice. And at the end we would get like 15 minutes of fully engaged machine learning and 30 minutes of motivational content. We should mix it.
Instead of just being 0 or 1.
That's the way.
And N is, and I guess N. Example. So
Ni, R to the Ni, superscript which has subscript. That's it. Life is like that. You go up, you go down. R to the Ni, and R stands for reality, real numbers.
Your shorter email, this feature vector will be shorter. Okay. So let's see. Just to give names to the algorithms we're going to develop, these are really very confusing, very horrible names, but this is what the community calls them. The model we talked about so far is sometimes called the multivariate.
Multivariate. Bernoulli.
And then model. So Bernoulli
Who was
coin tosses. So multivariate means there are 10,000 Bernoulli random variables in this model. Right? So event model.
I'm going to sleep, to be honest.
And the new representation we're going to talk about is called the multinomial.
Come on, I'm tired.
Event model. These two names frankly, these two names are quite confusing, but these are the names that I think actually one of my friends, Ash McCallum.
What was the second name? I missed it.
Named these two algorithms, but I think these are names we seem to use.
I have to watch this, guys. I don't want to get into the details,
And so,
but I have to watch it.
New model
I may need to take the ML course in MIT actually.
And because it's a generative model, it will model P of x comma y, which
did I register for it?
And using the naive Bayes assumption, we're going to assume that
I feel I have to take the ML course in MIT. Learn the coding part, I don't know. Talk to the teacher and say, dude, I will use ChatGPT for my codes. Or maybe up to that time I'm really just good with coding in Python and everything is good.
Because this is exactly the equation.
I feel if you do, I don't have to write down the homeworks and everything, I will be. I won't learn this shit. I won't learn. The thing is that if I really want to learn it,
confusing linear multinomial event model, the definition of xj and the definition of n.
I think it is necessary. I have to learn it. So
instead of a product from 1 through 10.
The thing is that I don't like the thing that everything is necessary. If your life is everything is necessary and you have to learn it, that's fucked up. If I have my part of the thing, okay, I can learn some stuff and they are necessary, but I have to make sure that I have my own part, that I do what the things I like. I don't say all the time I want to do the things I like. I accept that for a longer term, for the longevity, this small part you can learn even though you don't like it. Or maybe you just, you will like it once you learn it. Don't be open to it. But there should be these things that, okay, and I have this thing. I have this thing, so I can tolerate this part. And I hope one day this toleration turns into fun. So my area of fun comes from this, added to this, it will be this. Or who knows, it's not, maybe it's not linear, it's just fucking exponential. It's like this, it will be like, or it's like a square, rectangle, and it's like this, it's like this, and it's like volume. Anyways, I want to, I want to learn the basics, main ideas.
We assume that this probability doesn't depend on J, right? That for every position in the email, for the chance of the first word being drugs, the same as the chance of the second word being drugs, the same as the third word being drugs, which is why on the left-hand side, J doesn't actually appear on the left-hand side, right?
13 more minutes! Don't look at your fucking phone!
And so the way you calculate the probability...
You know what? I am going to repeat whatever he says. That's it.
And so the way that given a new email, a test email...
There is an email, we want a new email.
This probability is
there are some probabilities. We want to find the word drug inside that email. And we want to send it for informs or NIPS as the conference. That's it. So simple. Nothing complicated. Well, one thing is obvious here. He didn't use any form of mathematics that was new to me. It was just the same stuff, probability I know already. I feel, I was talking to Mesh the other day, and he promised me he will come to the show one day. But he was also saying, dude, this ML has nothing new. It's just they put words, like they name stuff different things, and you think, oh, this is a totally different thing. It's the same shit that I know. It's probability, it's optimization. I know all of it. I feel now I have this feeling that it's just this. I like Python. I know how to code. Just there are some syntaxes, there are some words and rules that I need to learn, and then I can take over the place. That's it. I'm here to take over, not to take apart. You can see the
indicator function notation.
ML and coding built on me by the end
when this actually
of winter,
so
probably. I say winter. Winter is too much.
So if you figure out
Whenever I hit my 225 on bench press, I will fucking finish this too. For 4 rounds in a row, I was doing 205.
Look at all of the words in all of the emails. And so
205, 5 reps,
is the word drugs.
and that was it. And I want to do 6 reps. I said, fuck it, I won't repeat this anymore. I will go to 20 and I try to do 6 reps
Indicator is not spam.
and see how it goes. If I can do 226 reps, then I come back to 20. No, sorry, I want to do 225. I was doing 5 reps of 205. Now I go 200, 6 reps, hopefully. 6 reps, 200, then I come back to 205 and try to do 6 reps. I hope that works. Wait. Let's see if math works. 6 times 200 is 1200, right? That's easy. Why did I use it? And 5 times 205 is, that's nothing. That's much less work and energy. Well, it is at least, it's about 200 less energy I am using for it. So 205 must be easier than 6 200. Probably my problem is not the energy, my problem is the
what is K? Not K, right? K
is the strength. Is the strength on my 6 rep, which I cannot do on 205 yet. Let's go.
How come? 1,000.
I feel I can do 6 reps of 200 easily. That's not a problem.
Cool. Yep. Yeah. Oh, I think I just realized why you said K. I think overloaded notation. When defining Laplace moving, I think I use K as the number of possible outcomes. Yeah, but here K is an index. Yeah, right. So, so you add to the numerator and add the number of possible outcomes.
I remembered something.
In this case, it was 10,000. So,
I'm not going to Instagram,
so
I promise.
Probability of x being equal to the value of k, where k ranges from 1 to 10,000. If you have a dictionary size, if you have a list of 10,000 words involved. So the number of possible values for x is 10,000, so you add 10,000 to 0. Makes sense? Cool. Yeah. Oh, what do you do words around in a dictionary? So there are 2 approaches to that. One is just throw it away, just ignore it, disregard it. That's one. Second approach is to take the rare words and map them to a special token, which traditionally is denoted UNK for unknown word. So if in your training set you decide to take just the top 10,000 words into your dictionary, then everything that's not the top 10,000 words you can map to a unknown word token, or the unknown word special symbol.
And again, that the student started asking.
Oh, why don't I write the so it indicates a function. So if so this notation, right, means well, so indicator 2 equals 1 plus 1. This is true, and indicator of 3 equals 5 is 0, is false. So that's the but this is a little formula that's either true or false depending on whether yi is 0. I guess if yi is 0 or 1, this is the same as not 1.
Nothing is special. Honestly, I'm not watching because he didn't say anything special. Okay, there is this, like, likelihood version,
Alright.
but
So I think both event models,
honestly,
including the details of maximum likelihood estimates, are written out in more detail.
more detail.
So,
So,
when would you use the naive Bayes algorithm? It turns out
naive
Bayes is actually not
Bayes.
very competitive with other learning algorithms. So, for most problems, you find that logistic regression will work better in terms of delivering a higher accuracy than naive Bayes. But
Naive Bayes is not very good, guys. I told you, he told us. Why are you doing naive Bayes? It's called naive Bayes. Well, bring your expectations lower, motherfuckers.
So if you are facing a problem, where you go is to.
I don't face problems, so I smash them.
It's really reasonable trees. And I think as you work on your class projects, I think some of you, probably a minority, will try to invent a new machine learning algorithm and write a research paper. And I think inventing new machine learning algorithms is a great thing to do. It helps a lot of people on a lot of different applications. So that's one. The majority of class projects will try to apply a learning algorithm to a project that you care about. Right? Apply it to a research project you're working on somewhere at Stanford, or apply it to a fun application you want to build, or apply it to a business application for some of you taking this on SCPD, taking this remotely. And if your goal is not to invent a brand new learning algorithm, but to take the existing algorithms and apply them, then rule of thumb I suggest to you is when you get started on a machine learning project, start by implementing something quick and dirty. Instead of implementing the most complicated possible learning algorithm, start by implementing something quickly.
Oh, he's teaching us something.
Algorithm, look how it performs.
So he says at the beginning of your learning, do not use the most optimal machine learning algorithm. Do something simple, get an idea, and say the most effective machine learning algorithm did the same. I added the last sentence myself.
So I think, we're just a Stanford, so we're very good at coming up with very, very complicated algorithms. But if your goal is to make something work for an application, rather than invent a new learning algorithm and publish a paper.
For applications, simplicity is more important than complication.
Technical, contribution. If your main goal is you're working on an application on
dude, if you are in Stanford, if you are in MIT, it doesn't mean you have to do complicated stuff. You have to do stuff that has huge impact.
Very complicated algorithm at the outset.
Oh, the weather is getting sunny outside.
So that you can then better understand how it's performing, and then do error analysis, which we'll talk about later, and use that to drive your development. One analogy I sometimes make is that
analogies are
if
good.
You are
let's
see.
So
if you're writing a new computer program with 10,000 lines of code, right? One approach is to write all 10,000 lines of code first, and then to try compiling it for the first time. And that's clearly a bad idea, right? And so you should write small modules, run it, test it.
Yeah, step by step, and check. Wow, that's actually very nice. He mentioned it. He says, if you're writing a code that has 10,000 lines, it's stupid to write 10,000 code and just run it afterward. You write a bit of it, check, compile it, and check if it is working. And then do that. It's very difficult to keep track of the whole process. You have to learn the step by step. I couldn't see that it is also true in coding. If you know how to do this step-by-step method in math as well, I think in math it's always you prove the theorem at the end. It's proven or not. I don't know how this is step-by-step. Well, I know, kind of. But still, it's less obvious that you put yourself on the line.
And I think a similar.
And you get a like fuck finger from the compiler system. No, your code has a
You build a simpler algorithm, test it, and then use the
bug
see
or
what it's doing well and see what's doing wrong to improve from there. You often end up getting to a better performing algorithm faster.
trial and error. That's it. That's what we call it. All right. I did this. Okay, that's it, I guess. Rest of it later. Thanks a lot.